Hi, I'm Zoe Ishwood, and I'm going to be walking you through the poster titled Nature in Motion, the psychophysical tuning of the visual system to the fractal properties of natural scenes in both space and time. So here's the poster itself. Feel free to download it on the VSS page it's uploaded to. I want to preface this walkthrough with the fact that I'm going to be talking very quickly through everything due to the time allocated for posters. So feel free to contact me if you have any queries or comments. My contact information will be at the end of this walkthrough. All right, so in terms of background, so what this experiment was trying to figure out was how exactly the visual system is tuned to natural statistical properties. Is it tuned to its photometric properties or geometric properties? And so natural scenes contain both of these properties despite appearing vastly different. And the photometric properties have to do with the way light is distributed across the scene, and the geometric properties have to do with the structure inherent in a scene. And so further, in terms of the photometric properties, so the luminance intensities in a natural scene can be plotted as a function of spatial or temporal frequency, and this reveals a linear relationship quantified as the 1 on F amplitude spectrum, which has a slope of around 1.2. And in terms of the geometric properties, this has to do with the statistical self-similarity across multiple spatial scales when you look at this in a natural scene, and this self-similarity classifies natural scenes as fractal. And so you can capture structure by using a measure known as fractal dimension. And so recent studies have found that distorting the photometric information of a static image whilst retaining its structural properties causes no change in visual sensitivity when measuring this using psychophysics. And this suggests that the visual system is tuned to natural geometric information over photometric information. And so a lot of this work was done in the spatial domain, and this tuning to structure has yet to be thoroughly investigated in the temporal domain, that is towards stimuli in motion. And so just spatially speaking, you can test this using random noise stimuli. So this noise stimulus has a 1 on F amplitude spectrum similar to that of natural scenes, and you can distort the photometric information by binarizing it or thresholding it, and you can distort it even further by extracting the contours from this thresholded image. And so if you were to measure the amplitude spectra across these 3 different image types, it would be vastly different, but if you measured their structure using fractal dimension, it would be very similar. And so basically what has been found in the past is that these 3 images give you the same sensitivity measures. And one way to test this in the temporal domain is by using random noise movies. Sorry, it's stuttering a bit here. My computer can't handle it. But you can use these movies to gauge how tuned the visual system is to structure in time. And so that's what we did in the present study using 3 different movie types, grayscale, threshold, and edges only. And we did this across 3 different spatial slope conditions, so the rows here, and 5 different temporal slope conditions ranging from 0.25 to 2.25. And we also contrast controlled the stimuli at 6% RMS contrast. And so here are some examples of all of the stimuli. So here are the grayscale movies. Sorry, it's a bit choppy, but basically what you can see, so across the rows are the different spatial slopes, and across the columns are the different temporal slopes. So if you have a shallower temporal slope, the movie appears more rapid than something that has a steeper slope. And this is what they look like for the thresholded condition, if my computer can get there. Here we go. And the edge condition. Here we go. All right. So in terms of the procedure, participants had to undergo a 4 AFC task where they had to pick the odd stimulus out or the one that was moving differently from the others. And so in this case, it's the bottom left-hand quadrant here. And in terms of the image analysis, I'll go through this very fast, but essentially what I've got plotted here are the measured input and output slopes in A for the different spatial slopes and temporal slopes, And in B, we've got input slope and output fractal dimension. And so the different lines represent the different movie types. And you can see that the lines here are all different. They're not on top of each other, showing that they have different photometric information, whereas if you measure their structural information, they're all quite similar. And so in terms of the results, we ran a mixed model ANOVA across all the factors and found that virtually everything was significant. So I'm just going to show you plots of the data now. And so this is for spatial slope and temporal slope, and I've got plotted each movie type as different lines. And you can already see that the different lines are showing very similar patterns of sensitivity and inverted U. Everything's peaking for a natural temporal slope and a natural spatial slope. And so since we don't see a shift in these peaks, this already suggests that it's the structure that the visual system really cares about in space and time. And here I've got plotted the different spatial slopes as lines as a function of temporal slope for each movie type, grayscale, threshold, and edges. And as you can already see, the pattern of results for these three different curves are essentially the same across the different movie types, particularly this inverted U for the green line, natural spatial slope, but there are slight differences in the pattern of results for this blue line here, which we're currently exploring further. All right, so to conclude, when viewing natural motion, our visual system appears to be preferentially tuned to structure rather than photometric information, and this may perhaps make sense due to the fact that structure is a more reliable statistical property in our environment. So it's more resistant to scene illumination. So when you're looking at tree branches, for instance, swaying in the wind at sunrise versus sunset, the inherent structure is the same across these two scenes. It's just the illumination that's different. All right, so thank you for listening to this walkthrough. Please feel free to contact me or tweet me if you have any contacts or questions. Thank you.